время работу разрешаю. Разрешили. Внимание.
Вот ебать это ебать!
On March 20th, 2022, humanity entered a new era, the era of wars with the use of hypersonic weapons. On this day, Russian troops used their Kinzhal, Russian word for dagger, hypersonic system in a combat situation for the first time. With its help, a large underground warehouse of missiles and aviation ammunition of Ukrainian troops was destroyed in the Ukrainian village of Delatin. It is noteworthy that this warehouse was built back in the USSR in the distant 1955 and was previously used as a storage facility for Soviet nuclear charges for their missiles. In order to protect such a critical object as much as possible, it was placed in a rock formation at a depth of up to 60 meters. It could only be destroyed by a direct hit from a thermonuclear bomb. It is too tough for any of the existing non-nuclear munitions. So how did the Russians manage to destroy this structure, very important for Ukraine, in the conditions of the war with Russia? Did they decide to use a nuclear charge, considering that Putin himself said that Kinzhal could carry a nuclear charge? In order to answer this question, let's first understand that this Russian Kinzhal hypersonic complex is, or if you stick to the official name X-47M2 Kinzhal, the world first learned about it from a speech by President Putin in March 2018, but the world did not believe him. They decided that he was bluffing and he was simply trying to intimidate the United States and the entire West. But 10 days later, the Russian Ministry of Defense showed the video with the test of this weapon. Later, more and more evidence began to appear that the Russians actually possess such weapons. So what is a hypersonic weapon, and how does it differ from supersonic? Let us remind you that hypersonic refers to a speed of at least 5 times the speed of sound, which is approximately 340 meters per second or 1,224 kilometers per hour. For convenience, the speed of objects, such as cruise missiles and other higher speed objects, is measured by Mach. If it is said that the speed of a rocket is Mach 2, this means its speed is 2 times the speed of sound. The Russian leader said that the hypersonic Kinzhal complex demonstrated a speed of Mach 10 during tests, that is 10 times the speed of sound. This means that its speed was approximately 12,250 kilometers per hour. Putin also announced the range of these weapons up to 2,000 kilometers. Also, experts who analyzed the images of the rocket believed it is as much. Its weight is approximately 4,000 kilograms, and the weight of the warhead is 450 kilograms. But the main thing in these technical characteristics is, of course, that stunning speed. Just think that the missile could fly over us from west to east, from North Carolina to California in less than half an hour, if it had more range. How the speed is achieved? We say all the time that the Kinzhal is a complex because it's not only a rocket, but also a platform from which it is launched, the MiG-31 fighter interceptor, which has been in service since 1981, is used as a platform. The choice of this aircraft was due to several reasons. Firstly, the MiG-31 is currently the fastest aircraft in service with the Russian Aerospace Forces. Its cruising speed is Mach 2.5 or 3,000 km per hour. Secondly, its maximum operating height is 20,000 meters. Having such characteristics, the MiG-31 is actually not a launch platform for the Kinzhal missile, but also an acceleration stage. The application of the Kinzhal occurs according to the following scheme. The MiG-31 with the rocket rises to an altitude of 15,000 meters and accelerates to its maximum speed of Mach 2.5. This way, the rocket itself needs to add not all 10 Mach but only 7.5. The plane launches it, and in a second, the solid propellant engine of the rocket itself is turned on. Experts citing a source in the Russian United Aircraft Corporation believe that it is the result of a deep modernization of the engine of the Iskander operational tactical ballistic missile with which Putin threatens Europe by periodically deploying it in the Kaliningrad region. From there, for example, it is only 500 kilometers to Berlin, less than 5-minute flight for Iskander. After turning on the engine, the Kinzhal rocket climbs along the ballistic curve according to various estimates from 25 to 50,000 meters. Note that, for example, at an altitude of 50 kilometers, the air density is 1,000 times less than that on the surface. Air resistance also drops by the same amount when the primary correction of the trajectory is performed using the data of the Russian satellite system below us. It was said recently that the US administration is considering the issue of disconnecting Russia from the GPS system, but for the Russian army, and in particular the Kinzhal complex, this is a meaningless measure. Upon reaching the upper point of the trajectory, the engine is turned off and the warhead is separated, which uses an inertial guidance system with satellite correction to hit the target. At the point of target, searching the homing head is turned on radar or optical. This three-stage guidance allows it to hit the target with an accuracy of 1 meter. Of course, the huge speed makes it difficult to intercept such a missile, but after all, the warheads of Russian and American intercontinental missiles when entering the atmosphere develop a speed of 6 to 7 kilometers per second. And this is 17 to 20 Mach, and yet the US military says the current US missile defense system will be able to fend off Russian missiles. Yes, it can, but only because these thermonuclear warheads fly on a ballistic, completely predictable trajectory. A missile defense rocket does not pursue a warhead the way an air defense missile pursues an aircraft or a cruise missile at a significantly faster speed. In the case of an intercontinental missile warhead, its speed may even be greater than the speed of anti-missile that's supposed to destroy it. Therefore, it's sent to the point calculated by the computer where it will meet the warhead and destroy it. Now imagine that you need to destroy an object that has a speed of 12,250 km per hour or almost 3.5 km per second, but at the same time moves along an unpredictable trajectory. Indeed, the warhead of Kinzhal can maneuver with overloads up to 25G. What is 25G? This characteristics means that at the speed of 12,250 km per hour, Kinzhal can deviate from the original direction of movement by about 0.6 degrees. It would not seem much, but it's such a huge speed in a second the missile will deviate by 250 meters. Imagine that you calculated the trajectory of the Kinzhal, sent an anti-air missile to the meeting point, and the Kinzhal deviated by 250 meters, a second before the meeting. Even if you blow up a nuclear charge at this point, it's important that it will destroy the Kinzhal missile, and very improbable. The shockwave of fragments will not catch up with it as it flies faster than them, and the radiation from a nuclear explosion which propagates the speed of light may not burn it. It is designed to withstand the large thermal loads resulting from entering into dense layers of the atmosphere at high speed. By the way, Russia used the Kinzhal twice in Ukraine, the second time in a large warehouse with fuel. If the first time the Russian General Staff justified the use of Kinzhal by the high strength of the object, then the second time was explained by the presence of dense air defense, which would be difficult to overcome by an aircraft or a cruise missile. Well, the Kinzhal missile, due to its great speed and ability to maneuver, is invulnerable. But how could it blow up a warehouse designed to withstand a nuclear strike? How could it break through the rock at a depth of 60 meters? After all, a warhead has a weight of only 450 kilograms. That is half as much as even the American Mark 84 bomb, which weighs 925 kilograms. But it breaks through only 3.3 meters of concrete, but not tens of meters. So did the Russians really decide to use nuclear weapons, but no radiation was detected at the site of the explosion? So what kind of explosive did the Russians put in the Kinzhal? Such an enormous destructive power is caused by the very design of the rocket. It's all about its speed. Any moving body has kinetic energy, which can easily turn into destructive energy. We see this well, for example, in crash tests when a car with dummies is accelerated and hits a concrete wall. Kinetic energy is directly proportional to the mass and square of the object's velocity. For example, the well-known Tomahawk cruise missile has a speed of Mach 0.75, that is 13 times less than that of the Kinzhal. But the kinetic energy of its warhead, which also weighs 450 kilograms, will not be 30 times less, but square 15, that is 169 times. Hence the huge destructive power of the Kinzhal, even without a nuclear warhead. Why do the Russians need the Kinzhal? Of course, it was not developed primarily for the war with Ukraine. Russia's numbers one enemy is the United States. Therefore, this weapon is primarily directed against them. The obvious targets for the Russian Kinzhal are the bunkers, where in the event of nuclear war the country's top leadership would be located. Another target is aircraft carriers. Since December 1st, 2018, 10 MiG-31s with Kinzhal missiles on board have been experimental combat duty in the Russian Southern Military District. Does the number 10 mean anything? Well, yes, this is the number of aircraft carriers that America has. You may agree that if the Kinzhal was able to destroy the anti-nuclear storage, then it is also guaranteed to destroy an aircraft carrier. So it is possible to defend against this deadly Russian weapon. Unfortunately, so far it may be possible only in the future. You might think laser weapons would help. No, they won't. So far we can confidently say that there are already combat lasers effective against drones and simple missiles like the Arab Qassam. In 10 to 15 years we can expect that there will be prototypes of lasers capable of destroying cruise missiles, but to burn through a Kinzhal missile with a laser beam is impossible for now, as it is designed for huge thermal loads. Of course, it is theoretically possible to shoot down the carrier of the Kinzhal missile, the MiG-31, but only theoretically, since this missile can travel up to 2,000 kilometers. The aircraft does not need to enter the enemy air defense zone. For example, the range of F-35C fighters based on aircraft carriers is only 650 nautical miles, or 1,240 kilometers, and even if they fly with external fuel tanks, then the range increases to 1,000 miles, or 1,850 kilometers. But at the same time, because of these tanks, the fighter will be perfectly visible on enemy radars. The most realistic way is to create an anti-missile that has a speed comparable to the Kinzhal, and it is capable of maneuvering with the same overloads. That is, to use the principle of anti-aircraft missiles to catch up with the target, continuously adjusting to the trajectory with the help of a homing head and destroy it. As a basis, you can take the RIM-161 standard SM-3 missile, which is installed on cruisers and destroyers, or in the form of ground installations. Its Block 2A modification can destroy targets at an altitude of 1,500 kilometers and develops a speed of 4.5 to 5 kilometers per second. That is even more than the Kinzhal, but it cannot maneuver